Well, let's start homework 2 and take a look at this problem. We have here binomial multiplication. It might be helpful to write it out like this. Let's see if we can do that. We're going to have 1 over 4 plus square root of 5 divided by 4, and then an I. And then we'll go ahead and make another one. Okay, so there we have it. And then we'll just go ahead and FOIL it. 1/4 times 1/4, that's 1/16. And then we have 1/4 times the square root of 5 over 4 becomes plus, well, we're going to have the outer and the inner be the same, so 2 square root of 5 over 16 I. And then we have the square root of 5 times the square root of 5, which is actually 5 over 16, and then I squared. Okay, and then we just have to reduce a few things here. Okay, so we'll go ahead and reduce a couple of these things here. 1/16, that's going to stay 1/16, so we'll write that here. 2 square roots of 5 over 16 becomes 1 square root of 5 over 8. Wait a minute, that's 8 when we reduce this thing. And notice that I squared is equal to -1, so there's an I here as well. We have 5 over 16 times -1, which is negative 5/16. So make sure you see that this became negative here because of that I squared being -1. And then we just need to subtract 1/16 minus 5/16, so we'll end this right now with negative 4 over 16. Yeah, that's actually 1/4. I'm going to write it this way for a second. Plus square root of 5 over 8I. And we'll just clean that up and make that negative 1/4. Plus the square root of 5 over 8. Notice that it's in the right form, a plus bi. I is at the end. You could write this with the minus sign over here. It'd be mathematically correct, but the form needs to be in this form, a plus bi. All right, looking at a random selection from the homework. This says to solve the equation in the complex number system here. If we solve this in the complex number system, that just means to include the i's if there are any, but I think you can see this is actually going to have two real solutions. That's just a difference of two squares. This is actually a very easy problem, but there's some nuance here. Let's see, we have x plus 5 times x minus 5 equals to 0, which now we know that x is equal to plus and minus 5. We can write it like this, plus and minus 5. You can do that inside the MyMathLab as well. Notice that these are real numbers, and real numbers are a subset of the complex numbers. So if you see the instructions say in the complex number system, that means you do include the real numbers as well. I don't know why I have a minus sign there. Let me get that fixed right there. It should just be straight minus 5. So really the answer should look like this. X equals to plus and minus 5, not negative 5. Yeah, don't look at that. That's what I'm trying to say here. Getting a little bit more used to the pen too as we go. Okay, so this is the answer right here for this. It's a plus and minus 5. Obviously, that's the negative and the positive. And this one has real solutions, but we still include them even though it says complex number system. I got another random one from the homework here. This is a complex number system again. This time we're probably going to have, well, let's just see. Can we factor that? I'm not sure if we can factor that. I'm going to go ahead and use the complete the square process because it's set up real easy to do it. In other words, x squared minus 10x leave some room is equal to negative 74. All I did was subtract 74 from both sides. And then when I add half of 10 is 5, 5 squared, I'm going to add 25 to both sides here. And what I'm doing is I'm just completing the square. And you can see from here that it wasn't going to factor anyways because this is going to have a negative answer over here. This factors easily into x minus 5 squared because minus 5 times minus 5 is positive 25, and if you add minus 5 and minus 5 you get 10. Over here you get minus 49. Okay, now you can see a square equals to a negative. That's going to be a problem. We're just going to go ahead and take the square root of both sides like this, and take the square root of both sides here. Don't forget to put a plus and minus in front of it. So you get x minus 5 is equal to, well, plus and minus, the square root of 49 is 7, and because there's a negative sign in there, we just make that 7, and that's where the I comes from. And then finally, we can just move the 5 over, so we have x equals to 5 plus and minus 7i. And you can use the plus and minus in your answer on MyMathLab. All right, we have here an equation that's quadratic in form. Obviously, it's not quadratic because this is a fourth power, not a second power. But because this second exponent is half of the first exponent, we can actually look at this as a quadratic. Let me show you. Basically, the easiest way to do it, I think, would be just to factor it. We would have two binomials here, and we would treat this just like a regular quadratic, where we'd have x. Let's see, it would be. I'm going to go with minus 9 and then x minus 1, because negative 9 and negative 1 make positive 9 when you multiply them, and when you add them you get negative 10. Of course, this wouldn't quite work because x times x is only x squared. So what we need to do is we need to put a square here and a square here, because x squared times x squared is x to the fourth. And that would be 1x squared minus 9 more, or minus 10x squared, and so on. So, and of course, this is still equal to 0. And this is how you probably could do it. And notice that both of these are the difference of squares. We have x squared minus 9, x squared minus 1. So that factors, although you could skip this step and just put plus and minus 3, I'll go ahead and write it, x plus and minus 3 here, and then x plus and minus 1 here, still equal to 0, which means that I have, for these two right here, I have plus and minus 3 as the answer, and for this one right here, I have comma, plus and minus 1 for the answer. There's 4 answers. It's a fourth degree equation. That makes sense. Those are 3's right there. Still getting used to this pen. Okay, so that's how you find the real solutions. Notice that there's no reason to look for any more because the highest exponent in this is 4, so that means there'll be 4 answers, and we have 1, 2, 3, 4 answers right there. All right, so here we have another one that says find the real solutions. Notice that it's important to pay attention here, the real solutions. There are 6 solutions to this equation, but that doesn't mean there's 6 real ones. There may only be 2 real ones from what I can see here, but remember, real solutions mean you do not need to worry about the imaginary solutions. And this one, again, 3 is half of 6, so we're just going to go ahead and factor this. Let's see if I can show you what I mean. If I was to factor it like a regular quadratic, I need 2 numbers that multiply to positive 64, but add to negative 65. And of course, we would have x minus 64, and then x, well, minus 1. And you can see that negative 64 and negative 1 make positive 64 when you multiply them. And when you add them, you get negative 65. Of course, this is just x, though, and x times x is not x to the 6. But if you put a 3 right here, you get x cubed here and x cubed there. And that's x cubed times x cubed is x to the 6. Then you have negative 1x cubed and negative 64x cubed. That's how you get the negative there. So this works out. And if we look at this right here, set each of these equal to 0 independently, we get this one here and we get this here. And then what I can show you here is that if you add 1 to both sides, oops, sorry about that, add 1 to both sides, you get x cubed is equal to 1, which has a solution. Let me come up here. X equals to 1. 1 times 1 times 1 is 1. Over here you get x cubed is equal to positive 64, and that means x is equal to 4, because 4 times 4 times 4 is equal to 64. So you get x equals to 4 for an answer. And those are the only 2 real solutions. And again, it said right here, real solutions. So that's it for this one. Alright, let's go ahead and continue with another one that says find the real solution. So again, we're not worrying about the complex, just the real. We could expand all this out, and that's not a bad idea, but I made a quick little observation here that right here I got s plus 8 and s plus 8. So I'm going to come over here and say s plus 8. We're going to go ahead and set it equal to a dummy variable, most commonly as u. Now again, that's an 8. I know it's kind of funny looking 8, but yeah, whatever. Okay, so what I have here is 8 times, well, u squared, because u is s plus 8. And then minus 15, well, u. And I'm going to put a minus 2 here equal to 0 because I just moved the 2 to the other side. And now you can see it looks quadratic at this point, so I'll go ahead and factor it, and let's see if I can come up with a factorization that works. I'm going to have probably an 8 here, a u, and then a u here, that's 8u squared. Let's go ahead and put a 2 here and a 1 here, and that makes 2. And then we'll make this one negative and this one positive, and that obviously gives me my result there. I have 8u times u is 8u squared. 8u times negative 2 is negative 16u, but we'll add one back to get negative 15. And 1 times negative 2 is negative 2. Now really though, u stands for s plus 8, so if I put that in there, I'll have this equation right here. Okay, so what I've done here is I've taken this u and I made it s plus 8, and then of course plus 1, that's a plus 1. And then here we have u minus 2, so s plus 8 minus 2, and then we can solve these just like you normally would. So you have 8s plus 64 plus 1 is equal to 0. So you have 8s, that's 65, so is equal to negative 65, and then you have basically s is equal to negative 65 divided by 8. And up here, if we want to work on that, this is one of the answers right there. Over here we have s plus 8 minus 2, so that would be s plus 6 equals 0, so then you'd have s is equal to negative 6. Let me circle that answer there too. Try to fit it all in on one page. And here we just got one more that's quadratic in form. Doesn't quite look like it here, but if I write this for you, this becomes x plus x to the 1/2 minus 30 equals 0. I just went ahead and made this square root of x equal to x to the 1/2 and moved the 30 over. Now you can see 1/2 is half of this invisible 1 that's on this x right here. And we can go ahead and factor it the way we normally would, like this. If it was quadratic, we'd have, let's see, x, I think that would be plus 6 and x minus 5, and that's because positive 6 times negative 5 is negative 30. 6 minus 5 is the 1 that's in front of here, but of course that would be x squared, and that's just x, so we'll put a 1/2 here and a 1/2 here. Okay, now we have the equation x to the 1/2 plus 6 is equal to 0, and x to the 1/2 minus 5 is equal to 0. Okay, so what we can do now is we can use the fact that x to the 1/2 is equal to the square root of x and change that x to the 1/2 to the square root of x, and then we can solve, or try to solve this equation. We get the square root of x is equal to negative 6, which this has no solution. Because the square root or principal square root can never be negative like that. And there's no I or anything that will ever help. We can't put a number in for x that will give us a negative square root unless we have a negative out front here. But over here we have the square root of x is equal to positive 5, and then that means that x, well, when we square both sides, is equal to 25, because what is the square root of 25? It is 5. So this is the only answer that we have right there. Alright, let's go ahead and talk about this one. Notice that this is also quadratic in form because, well, it's not quadratic, but 1/4 is half of 1/2, right? Because 1/2 cut in half is 1/4. So let's go ahead and treat this like it was a regular quadratic, and let's see if we can find two numbers that multiply to 9 and add to negative 6. And I think you can see clearly that's going to be t. That's a funny looking t, I know, but minus 3, and then t minus 3. Of course, t times t is t squared, and that's 1/2. So we're going to put a 1/4 right here. Don't forget this is equal to 0. 1/4 plus 1/4 is 1/2, and of course you can see that that makes negative 6t to the 1/4. So we just need to solve this equation, t to the 1/4 minus 3 equals 0. So that means the fourth root, let me see if I can get that, fourth root of t is equal to 3 when you add 3 to both sides and rewrite this as a x as a radical, and then we just raise it both sides to the 4th power, so t is equal to 81, because 3 times 3 times 3 times 3 times 3 is 81. Okay, so this is a word problem about mixture, and it's a little small here, but if you read through it, you can see that we're basically mixing some Earl Grey tea with some orange Pekoe tea, and I've created this table here to show you how this works. Let's start with the quantity right here. We don't know how much the quantity of Earl Grey is going to be, so we're going to call this one, I guess, X. That sounds good. And we don't know how much the orange Bako is, so we'll call that y. But we do know from the problem right about there, it says we're supposed to get 200 pounds of the tea when we're done, so that'll be 200. We do know the price of the Earl Grey. The Earl Grey sells for $4. The orange Pecos sells for $2, and the new blend is to sell for $3.50. Okay, that's a 3 right there. Okay, so then what we do is we just multiply across. So this is multiplication. This is 4x. This is 2y. And of course, 350 times 200 makes 700 here. Okay. Now what we have here is a system of equations that we're going to get out of this, which is going to be from right here. We see that x plus y has to equal to 200. And then we also have that 4x plus 2y has to equal to 700. So we have a system of equations there that we have to solve. Alright, and to solve this system of equations over here, there's a couple of different ways. You could actually say that y is equal to 200 minus x, and then substitute that y into this y right there and use the substitution method. I prefer to use the elimination method. X plus y equals to 200. Then we have 4x plus 2y is equal to 700. And what we can do is we multiply the top equation by negative 2, because that will put a negative 2 in front of that y. And what you'll get is negative 2x minus 2y is equal to negative 400. And of course down here we have 4x plus 2y is equal to 700. Add those two equations together and you get 2x is equal to 300, which means that over here x itself is equal to 150. Okay, so we now know the answer to the x, and of course together they're supposed to be 200, which means you also know y has to be equal to 50. So this is your answer right here. Of course, don't forget to answer it, and this is why you want to use these labels as the Earl Grey. So we have the Earl Grey is equal to 150 pounds, and then the orange Pecos is just 50 pounds. And that's a pound symbol right there. That's what that was supposed to be. Okay. Okay, we got one more of these for our second homework, and it's another mixture problem. Here we have a nut store selling some cashews and peanuts, and I put cashews and peanuts, just CMPA, just so I know. We can see the price of the peanuts there. Actually, cashews is first, so we come over here to the cashews price. That's $4 per pound, and it looks like the peanuts are only $1.50. Okay, we're going to mix them together, but notice this time it says that we actually have 90 pounds of peanuts. So we actually have 90 pounds, so we can fill in that box. We just don't know how many cashews. And we do know that the mixture is supposed to be selling for $3.50 when we're done. Okay, so that's all we get out of this word problem up here. So what we have down here for the total is actually going to be x plus 90. And up here we'll have x times 4, or 4x. And here 1.5 times 90, that's going to be 135. And then down here we have 3.5 times x, so 3.5x. And then plus, I'm coming outside of my box here a little bit because I didn't make my box big enough. 3.5 times 90, which is 315. Okay, so notice that this is all together right here inside this box. I just didn't have enough room to write it. That's 3.5 times x plus 3.5 times 90, which is 315. Okay, so this time we only have one equation. It's right there. Let me write it up here. We have 4x plus 135 is equal to, I'm going to leave myself some room here, 3.5 x plus 315. Okay, so let's go ahead and solve that equation. I just wrote it a little bit nicer here. Let's go ahead and subtract 3.5x from both sides. So that'll actually give me 0.5x is equal to, and if we take 135 and we subtract it from 315, well, it comes out to be 180. Okay, and then we want to divide both sides by 0.5 or multiply by 2, whatever you want to say, so that we get x is equal to put equals there. X equals to 180 divided by 0.5, which is 360. Let me write that down here so we know whether it's pounds or whatever. I'm not sure just yet. I gotta go back and look at the problem, but I think it is pounds, yes. So let's write pounds down there. I can fit it in LBS here. That's supposed to say pounds. Okay, so that wraps up homework 2, and you guys should be able to get most of it done. Good luck.